Hello, everyone, and welcome back to our second lecture of Summer Internship 2021 at PioPetro. I hope all of you are doing well. It's me, Rahima Babayba again, and I'm a graduate from the University of Aberdeen. I have finished my Master of Science in Petroleum Engineering, and I'm going to be your moderator for today's session on behalf of Arab Oil and Gas Academy. Today's webinar is going to be about systemic risk management by Dr. Fouad and his amazing team. Now I shall introduce our instructors to you. Dr. Fouad is a professor of drilling rock mechanics at Petroleum Engineering Faculty at Cairo University. He worked as a drilling consultant and drilling manager at GAPCO from 1977 until 2001. He's a coordinator of the Risk Engineering Master. He's a chairman of the NGO Risk Mitigation Society. His research interests include rock mechanics, application to drilling, improvement, drilling performance, and risk management. Dr. Fatma El-Zahra Hanafi Ashur is a professor of chemical engineering, Faculty of Engineering at Cairo University, and she's a former department chairperson. She also worked as a director at Cairo University at Center of Hazard Mitigation, Environmental Studies and Research. Her research areas are petroleum refining and processing, conversion processes of biomass. She is also president of the RMEI. Dr. Salma Fouad Dawara, she's a Dean Faculty of Medicine at Galala University and Professor of General Surgery at Cairo University. She's also a founder and former head of General Surgery Department at Armed Forces College of Medicine. She has a postgraduate diploma of medical education from Dundee, UK. She is a member of the Scientific Board Egyptian Fellowship of General Surgery. Moreover, she's a former national trainer in Harvard University Program for Executive Managers and Emerging Leaders. She's a certified international trainer from International Board of Certifying Trainers from Netherlands. She's a former director of Medical Education Development Center. She's a member of Egyptian Society for Risk Mitigation. Dr. Hanan Hassan El-Sarsi, she's a professor of chemical engineering at Faculty of Engineering at Cairo University. She's a general coordinator of Credit Hours Program and coordinator for international students. She's a member of Egyptian Engineers Syndicate and Egyptian Society of Engineers. She's an ex-member of the Egyptian National Committee on Women and Science and Technology. She's a member of the Egyptian Society for Risk Mitigation too. Her research areas are quality assurance activities, risk environmental engineering, management system audits, materials engineering, and soft and communication skills. Dr. Ziad Rezk, he's a HC manager at Petrocas company in Egypt. He has a PhD in electrical and a higher diploma in electrical engineering and higher diploma in risk engineering from the Faculty of Engineering from Cairo University. He's an interim lecturer at Faculty of Engineering at Cairo University. He's a certified safety professional from Board of Certified Safety Professional in USA. He's a professional member of the American Society of Safety Professional. Engineer Rim Said Muhammad Abdullah, she's a process improvement manager at Pacer Consultants from Egypt. She's an interim teaching assistant at Faculty of Engineering at Cairo University. She has a PhD, she's doing PhD dissertation in Operational Research and Management at Cairo University. And she has a master in Engineering Risk Management. She has a professional certificate from Project Management Institute from USA and professional diploma from American University at Cairo. She has a diploma of heating, ventilation, and air conditioning system from Cairo University, and she has done her Bachelor of Science in Mechanical Engineering from the Cairo University. Now, before starting today's session, I'd like to mention that you can ask your question from question and answers part, and 3 to 5 questions will be answered by Dr. Fouad and his team. Let's welcome our instructors. We are delighted to be here today. Dr. Fouad?
Okay, thank you, Rahima, for your presentation of our team. Remind you, yesterday we talked about all of what's in blue, and today we will devote ourselves to something practical, touches the reality, significance of risk, some tools for risk management, some thinking models to broaden the view, the perception, the remembrance, and we go to application before we conclude by a call for a forum or a meeting or a gathering for signs of danger, and we conclude after that. In order to make a link between yesterday and today, yesterday Dr. Fatma prepared something, but for just my side, I, I, I just didn't remember. So, Dr. Fatma, tell us
Yes.
what you wanted to say yesterday.
Okay. Thank you, Dr. Fouad. So, as we are going to back to talk about the origin of words of risk and hazard. So, just a quick reminder that hazard comes from the Spanish hazard, which means the roll of dice roll. So, and this means that it comes from the Arabic zahr, which is dice in Arabic. Also, the French word hasard, which is le hasard, we don't pronounce the H and D. This means that it comes from what? From risk, which is it is the Arabic word risk that can be the God-given or fate. So, and then it has been developed in the medieval times that risk can come from the Greek word, which is rizikon, which are roots coming and they protruding and they can block your way, or the Italian word, which is risio, which is risk too, and the Spanish risco, and the Albanian risk, and the German risico. So this is the root of the word risk. And then it is always adventure. It's always fear of loss and risk. This was the roots of the word risk, and that it has developed with insurance, with maritime insurance, and all this. Dr. Fouad.
Okay, thank you, Dr. Fatma. I remind you also one of our team is called Ziad Risk.
Yeah.
Ziad Risk. So risk could be a noun, could be also take different form. Okay, today we are going to talk about tools, what tools we use for quantitative, qualitative. Dr. Ziad will touch this, and thinking models and application. You see this what's written below, risk is not bad or good. In Arabic, it can carry both terms, but mostly good. But in Europe, and what we are talking about is the bad side of risk. But it could be bad or good, it just is. We should not argue about it, and it will exist whether we choose it to acknowledge it or not. It is impregnating, penetrating all our life. The thinking models we are going to talk about is just for enhancing creativity and perception and remembrance. Why? Because as we talked yesterday, risk is relative. Relativity in risk is very high. No one, sometimes we don't agree on the same word. The same word may have two different senses, two different meanings, like risk. Risk in Egypt, it carries a good sense, but also it has some ingredients of bad. It depends on the culture, the who is hearing. Okay, tools are numerous, like what you say, and Dr. Ziad is going to talk uh, about some of them. Dr. Ziad.
Hello to everyone. Yesterday, we learned about how to manage risk and its effects on objectives requires a structure. International standard gives us two important standards for this. ISO 31000 that covers risk management process, and ISO 31010 that covers risk assessment techniques. Here in the photo, we will see the process according to ISO 31000. That process includes communication and consultation, scope, context and criteria, risk assessment, which include risk identification, risk analysis, and risk evaluation. After that, risk treatment or risk control. After that, monitoring and review, and recording and reporting. During establish purpose and scope of the organization should select or develop a risk assessment matrix that the stakeholders agree to be used in the risk assessment process. This key component is used to define and determine risk levels within an organization. The context of the risk assessment assignment will determine the size and the makeup of the team needed. The risk assessment team should include a cross-functional group of individuals who are familiar and knowledge with the hazard and operating being. Risk assessment about 3 to 10 members seems to work well. Less than 3 members may not provide enough insights into the risk assessment. Here there is the process. The process hazard risk identification, risk analysis, and risk evaluation. Risk hazard and source of risk. If risks are to be assessed, hazard must be first to be identified. This is first step. Number 2, risk analysis. Risk analysis following the following task: determine the severity of consequences, estimate the likelihood of occurrence, assessment the effectiveness of existing control, and estimation of the risk level. And after that, risk evaluation. Risk evaluation involves comparing the estimated risk levels with the defined risk criteria to determine the significance of the level and the type of risk. Okay, next. Here is the tools that come from ISO 31010. We have many tools like hazard and probability studies, what if analysis, and layer of protections that detect the layers of the systems and evaluate the control system in the system. FN curve that's used in quantitative risk assessment, risk indices. All of these tools of risk management, you must select a tool that's suitable to every step that explains in the last slide. Next. Today we will take an example of what if hazard. What if hazard analysis is a tool that use to identify the hazard, is well established and widely used. It is a qualitative method. We learned yesterday that there are many tools, qualitative and quantitative, and there are also many tools semi-quantitative. What if hazard analysis is a qualitative method for identifying and analyzing hazard scenario, and existing and needs control. What if uses a multi-scaled team, as explained now, and answer the series what if type questions. What if happens if every case in the system. The method has a relatively loose structures. It is very common methods, and it is a very widely methods that used with checklist. The first step on what if analysis, define purpose and scope. That's a clear purpose statement that it's specific and measurable. Number 2, assemble team. Based on the purpose and scope, the team should be selected to include experience, knowledge, and individual. Number 3, communications, objectives, and requirement to team. The facilitator should clearly define the purpose, scope, and objectives. Number 4, gather and review information to support the analysis process. General information surrounds the system, the history and the manufacturer's specifications and instructions is gathered by the team facilitator, leader, and provide the team for review. After that, breakdown into tasks elements using information gathered. The activity system that is subdivided into sequential tasks or elements for individual analysis. After that, general what-if questions for each task. For each task element, the team being to think of questions that being with what-if to identify possible hazards and hazard scenario. After that, respond to each what-if questions. For each what-if question, the team discuss and determine the causes, consequences, and existing safe control. After that, determine the need of additional control. After that, report the results to management and what if questions answered in the spreadsheet like this. The output of the what is hazard analysis is a table like that, and it is the output of the study.
Okay. Dr. Hanan is going to talk about the other concepts.
Hello, everybody. Today I will complete with you the common concepts of risk. Please, from now, you should wear black glasses and act as a movie director to know that it's not all of the risk or all of the elements are clear or known. For that, if you saw a Titanic film, you know that all of them appear to the surface. From years ago, only health and safety and the environment is the three things they thought. They forgot loss of data, loss of time, of image, all of this. The Eisenberg model is useful in estimating and evaluating risk. It's considered possible hidden elements, especially when handling cost, because we have it's a guide selection of multiplier factors to apply on direct cost or indirect cost to account. Because we have a direct cost, which is very clear, like sorting, warning, inspection, all of this. But we have some indirect costs which are not seen, like conflict, loss of sales, admission cost, legal costs, all of these are hidden. For that, you should not look to the face or the surface. For that, the cost, you know that the cost is not equal what you see. It is the cost, a cost will be multiplier of factors to apply on direct cost, not work on the direct cost. You should multiply factors to apply to account for the unknown or potential cost.
Okay.
Next.
Here
we in risk, there we are the useful model for expanding vision of hazards. Eisenberg, you should see something you're unknown and some unknown. Unknown, everybody can see it, but there is a hidden unknown. For that, the recommendation that all of the team told you, you should think about system thinking, because it is useful to see the unknown and the unknown. You don't see trust. There is no trust. There is a limited sharing, or there is a low perception. All of this you should take in your concentration. Some political, some culture, some legal factors, maybe in the post-risk management. You should look not for that. I recommended you should wear a black glasses to see what's the hidden. You don't trust all of the known things. Thanks, Doctor.
Okay, thank you, Dr. Hanan. We already covered what if and iceberg, and go back to Dr. Ziad for the model of risk control.
Yes, Dr. Fouad. Here is a model for risk control according to OSHA. There is 5 hierarchy of control: elimination, substitution, engineering control, administrative control, and DBBE. Maybe you find another figures for another standard in the United States, like prevention through design. They introduce the risk control as 7 layers. Begin with avoidance and increase 1 layers between engineering control and administrative control. That's called warning. But here we talk about OSHA standard in United States. First, elimination. Elimination should be the first choice when in the design or redesign stage, since they have the greatest risk reduction and reliability factor, and generally are the most cost effective. Number 2, substitution. Substitution of a less hazard component or element for a more hazardous one, such as non-flammable chemical for a highly flammable chemical, is considered very effective. Number 3, hierarchy 3, engineering control and design changes to design changes to existing systems can be applied to contain or prevent exposure to a hazard. Engineering controls are considered effective and reliable when the application is functioning as intended. An example might be a well-guarded machine with interlock that prevent access to moving parts that could cause harm. Administrative control, such as policies, procedures, training, are only effective if they are known and followed. The last one, PPE, personal protective equipment, is commonly used as the last defense against hazard exposure in the workplace. This is the weakest layers of control because that layer, methods depend on the human to applying the instructions. You can give the workers helmet and safety boots, but and train him to use it, but he can didn't apply this and leave them. So it is the weakest against hazard exposure. Their effect is limited and dependent upon the proper selection, use, and care. Here, hierarchy of risk control, we here look at how to risk control. Risk control can be split into 2 things: loss control and risk finance. Loss control include 2 items: risk avoidance and risk reduction. Risk finance include risk retention and risk transfer. We can explain more expressions like risk avoidance. Risk avoidance is avoiding completely the activity, giving the risk. For example, never travel by air to avoid the risk of being involved in a mid-air collision. That is risk avoidance. Risk elimination, the difference between risk avoidance and risk elimination, risk elimination usually has a wider meaning. It implies removal of risk without necessarily ceasing an activity completely. Example, redesign of a process to remove a particular risk without stopping the activity. Reduction, here we can see risk reduction. Reductions mean avoidance or elimination may not be possible. So we need to a risk reduction. For example, if would involve closing the factory with the loss of all jobs and the high associated cost, risk reduction may be as an effective, might be more economic and visible solution. Risk retention, here the loss is to be financed from fund within the organization. So we have to consider where the funds are come from. Example, pay losses from current operating fund. Risk transfer, involving transferring the risk to another party, such as insurance. The loss is financed from funds which originate outside the organization. The second main way is to engage a contractor who will take on this. Here, severity and probability. If the severity and probability and the frequency of probability low, we must use risk retention. And if the severity and the probability is high, we prefer risk transfer. Outsourcing maybe gives the job for an contractor.
This is largely practiced in the oil industry. We go to a contractor to run a sophisticated tool. We pay him much more than our employees, and this is normal. Now, Reem, I think you are ready to talk about risk management and decision making.
Yes. Thank you, Dr. Fouad. Here I'm going to talk about the decision-making process and its relationship to the risk management. Actually, these decisions and risks are very correlated to each other. When we face risks, we need to take appropriate decisions to reduce this risk. But at the same time, our decisions may entail new risks. So it's a cyclic situation. What we need for this, we need a systemic approach. This is what we are talking about yesterday. For that, we have an analogy between the risk management process on the right, on the left, and the risk management process on the right, and the decision-making process on the left. In decision-making, just like in the risk management one, the first steps are identifying the process and the possible solutions. Then we evaluate these solutions, making the decision and testing it. If the problem is solved or not, we need to change the decision. Both processes are total quality. Again, plan, do, check, act, or improve. The next slide, please. Dr. Fouad.
About uncertainty.
Yes, it's about uncertainty. Uncertainty, when we talk about uncertainty, we have to remember the iceberg model. As we may see, each problem is a function of two factors: ability to identify the problem and the uncertainty of the information. As you see, these two factors construct the knowledge matrix. We have, with the same color code of the risk one, we have green for known unknown, that's things that we are certain of, and we need to share it. As an example for this, we know that some equipment can only be supplied by a certain vendor. Then we have yellow, known unknown, something that we know, but we cannot predict. Example for this, if I started the construction in January, we may have 4-day delay because of bad weather. We cannot predict the bad weather. Going to the orange category, these are some things are known by others, but we don't know it. As an example, there is new regulations will be implemented. Only the financial department know this information, but he didn't share it yet. And finally, the ultimate risk situation, which is red category, unknown, unknown. We don't know. We don't know what we don't know. This, as an example for this, if we have a surprised by a severe earthquakes in a non-seismic zone. Then we are going to talk about how to take a decision under risk. This concept is used to assess the possible outcomes for situation, provided that we have an estimate for the probabilities of these outcomes. Here, I propose two models, expected monetary value and decision tree. For example, for expected monetary value, if we need to construct this building, and the building cost is depending on several factors. Of course, we don't know all of them. So we have three scenarios for the outcome. The optimistic scenario with relatively low probability, 20%. If it happens, the building will cost 150K. We also have a pessimistic scenario where there is a chance for some unexpected increase in the rates of material or workmanship. If this happens, the building cost will raise to 300K. And the probability of this scenario is 30%. What about something in the middle? If I collected sufficient information and pay attention for the planning before starting the project, this is the normal case. This is the most likely situation with a probability 50%. Then the cost will be something in between, say 225K. If I am a manager and I need to assign a reasonable budget for the project before starting, what can I do? If I choose the optimistic scenario and what happens was the pessimistic one, I will face a shortage in financing my project. Here, expected monetary value, EMV, will try to help us having a kind of compromised scenario by multiplying each probability by the value of the outcome, then summing up and giving us a value for this compromised solution. Here, it's about 243K. You will notice this value will lead to saving if we have the optimistic or the likely scenarios. But if we have the pessimistic one, our loss will be reasonable. Then we are going to the next slide, the decision tree. It's another model. Here I need to take a decision, as an example, whether I upgrade an existing plant or constructing a new one. So based on the market studies, I have two outcome scenario with known probabilities. I have the scenario of having strong demand, 65%, or weak demand, 35%. The values which are in the boxes are the cost of each alternative. The values under arrows are the revenue of each scenario. So we have the right side values represent the net profit for each scenario, regardless its probability. Now, how can I take the decision? I need to evaluate these scenarios. I will calculate the EMV for each decision alternative, and you will see that the alternative of upgrading the plant has a higher value for the EMV. So to conclude, we have several models that help the project manager to make his decision based on evaluating the risk. Thank you.
Okay, thank you, Reem. Now this is the turn of Dr. Fatma. She likes Gruyere, fromage, Emmental, and she's going to talk about what's relationship between this Gruyere and risk.
Thank you, Dr.
Welcome.
Thank you, Dr. Fouad. So the concept of barriers in risk prevention, which is known as the Swiss cheese model, as Dr. Fouad has mentioned, the Gruyere or the Emmental, which is with holes, which are with holes. So this concept has been developed according to what? Based on, it is based on what? It is based on the two approaches, the multi-layer defense model developed by James Reasons, and the other one, the tripod theory of accident causation developed by Shell International Exploration and Production. So if the barrier they are talking about, if the barrier controls fail to manage the hazard, the undesired consequence may occur. We have many layers. The hazard passed by many layers containing holes. So even the best barrier will not be perfect. It may have holes. So as we see here, undesired event will happen, and then we won't be able to control to prevent escalation, and we will have consequences. So this method, this model is developed to really identify and to understand some of the accidents happening. Next slide, please, Dr. Fouad.
These are the aviation.
Yeah, the aviation. We have here aviation accidents. Aviation accidents and incidents, they are caused by, they range from human factor related mistakes and pilot error rather than mechanical failure. So we will have many reasons, but we will have here 50% of airline accidents between 1959 and 2005 were caused by human-related factors. This is according to a study conducted by Boeing, while only 17% of the accidents were caused by mechanical issues with the aircraft. We have here in this photo on the right, it's the worst accident in aviation history, the Tenerife airport disaster. It was caused by a chain of events and error that contributed to this catastrophe. Pilot error, communications problems, fog, and what is unexpected also, airfield congestion. This was due to what? Due to a bomb threat and explosion at another airport. So the pilot was not aware. People were not expecting this. So this is a combination of events and effects that has caused this worst accident in the aviation history. Okay. Thank you.
So Fatma, you also, maybe you need to select some of these signs that belong to chemical engineering and share it with Dr. Ziad.
Okay, thank you. So we have here some of the signs. I'm going to talk only about the chemical engineering or the chemical science. We have here safety comes first. We have safety showers. Every lab should have safety shower, and of course, and we have also to have eye shower, because we have problems of drops of acids harming the person, the lab technician, or the person working at the lab, or they may harm their eyes too. We have also flammable, this sign to say that these are flammable or combustible. We have the other sign, we have corrosive. The corrosive one, because we deal with acids also, so it has to say that it is corrosive. We have the biohazardous. We have biohazardous material, so we have to take care not to touch. We have also the first aid kit, because it may happen in the lab. We will have accidents, spills, or all this, so we have to take care of the students. We have also garbage disposal. We have also garbage. We have also this skull. It shows poison, which are toxic chemicals. So these are the signs that we may encounter in our chemistry labs. Dr.
Ziad. Okay.
Yes. Here, science, the word science are better than word. Signs are signs are administrative controls, and we select signs after make a study of hazard application in the facility. There are many advantages of science, like eye-catching, visual, quick to interpret, no language barrier. Conveys a message to a wide audience. Here, maybe there is a program in OSHA that called hazard communication programs. Hazard communication programs asked the facilities to imply these programs to identify the hazard, chemical hazard and physical hazard. Like a physical hazard here, like confined space. And put labels and the signs in everywhere that the workers may face this hazard. As we told that signs are administrative control and must be followed by the workers and the manager of the facility. Dr. Fouad.
Okay. Now I'm going to talk about a model that depends entirely on system thinking. When you have something, either you buy or you analyze or something happens, we would like for the system thinking calls us to consider certain steps, the design state or the new state of something we would like to buy. If we buy it, then we will operate it and do performance on it. There are risks in operation, risk in performance, and these should be evaluated. Risks during maintenance. Maintenance, it is withdrawn from services for a certain period of time. This is allowable, but when it gets very long, this is undesirable. We handle the object safely. So it should be designed, the safety designed in it. We should consider the relationship between the object or the operation or the process and the human and the environment, its impact on. And their impacts or risks should be within the tolerable or even acceptable. First, tolerable after, but if it gets into the intolerable, sometimes we need to send it to maintenance or sometimes to junk it or scrapping it. Okay, what is the impact of what we consider on resources and assets? You are going to buy a car. What's gasoline consumption? Is it polluting the environment? Or if you are buying a software or know-how, is it compatible with what you do? And finally, in the evaluation, in buying the product or in renting the product, we should consider how to end services with it. A radioactive material may cover the 5 or 6 points at the beginning, but it's very expensive to put it aside, to get it out of services. Mise au revue as a junket, put it in junk. These 7 points, if you evaluated and included into an Excel sheet with a point system, each one out of 10, you can evaluate a computer you would like to buy with a different other computer, and then you add all the number, and the one giving you the highest number, it could give you the best risk or the highest risk. You divide the cost by the point, and then you get the cost of 1 point. If you are looking for low risk, then if the cost per point is low, then this is the one to select. This process, sometimes it's used in the oil industry and for evaluation of tenders. But evaluation of tenders sometimes depends on the current status, the present time. Maybe the evaluation doesn't go further about the future. So we need to include the initiation, the design, the operation, the maintenance, the safety, the interaction between whatever we deal with, the human and the environment, its impact on the resources, and then when it is finished, this way we can cover all aspects of the object during its service life, and this way we consider all the resources and the impact of this on the system. I'm calling for Dr. Hanan just to continue the talking about.
Okay, to conclude what we said, we want to make a risk management that we said that we have 5 steps. The first 4 steps, which we called risk assessment, we should at first, at 0 level, you should agree with the terminologies. Because if you are talking with another language, you didn't estimate it or assessment will be right. So you should define and agree with the terminology, so all of the team will talk in the same language. Then begin to define the system and its components, as we said, four corners, with actors and the environment and the process and everything in done. Then define the interaction between components. To define interaction between components, you should think not linear, but you should think by system thinking, because as Dr. Fouad said yesterday, the correlation will be not linear, but you should multiply n times n minus 1. For that, you should define the interaction between all the components in the system, which you do its boundary and separated the system from the outside. Then after that, you will wear a black glasses and become to extract hazards. And every hazard, you should estimate probability of undesired event to happen and the negative consequence, which is called severity S, because we estimate the risk number, which are the multiply of probability times severity. After you make your estimation, you begin to evaluate. When you evaluate, you want to know the value of the risk. Here in our lecture, we make our matrix or our levels for 4 levels. You can do more than 4. But as Dr. Fouad said yesterday, we prefer to be an even number to be more honest, because if you any choice of odd number, you may choose, if I choose 5 all of time, I will choose 3. For that, you should take an even number. Here we took 4 times 4 in matrix, and we in the safe zone is green, and the highest risk is red, in between yellow and orange. After you evaluate your risk, if it is accepted, you go to documentation. If not, you will pay, you should apply control to prevent by decreasing probability or protect by decreasing severity. Dr. Ziad will complete about the 4 risk rank and the diagram. Let's go.
Yes.
Please, Doctor.
Here we will see the risk matrix. Risk matrix is a method for measure the risk. It is between probability and severity. If we use words to explain risk matrix like low, high word, it is called a qualitative risk matrix. But if we use number 1, 2, 4, it's called a semi-quantitative risk matrix. Another figure is called alarm. As alarm is abbreviation of as low as reasonable practicable. These expressions come with the study is called QRA. That's called quantitative risk as a QRA, quantitative risk analysis. If we divide the risk analysis to 3 categories: qualitative, semi-quantitative, and qualitative, all operations in any facilities, 100 of these operations may apply a qualitative risk matrix, like HAZOP and what if analysis and checklist brainstorming. This is called what if analysis. It's called qualitative risk analysis. But when we use semi-quantitative risk matrix, 10% from only the activities, it's called semi-quantitative risk matrix, like layer of protection analysis. In the third stage, 1% called for QRA, that's using for a petrochemical industry that is impact on the environment and safety, and maybe fires and explosions that affect the surrounding of the facility. That's called alarm. Alarm means as low as reasonable practicable. Is the practical applications of risk reduction using a cost-benefit analysis. When applying a QRA, the risk, the output risk may be acceptable or non-acceptable or alarm. Alarm using another study with that is called cost-benefit analysis type approach. Means alarm is a level of risk that is acceptable, which cannot be reduced further without exceed the benefits. Another meaning, steps must be taken to reduce the risk as low as reasonable practicable. It is a UK standard. Next.
Okay, and next is talking about the measures. Okay.
Yes, this expression, the risk indices. Risk indices are single numbers or tabulations of numbers which are correlated to the magnitude of risk. This using in the QRA and the figure beside it alarm. Individual risk, there is another expression, individual risk, that calculates the risk to a person, societal risk, or if that's the risk to a group. All these expressions is used in QRA study. Fouad.
Okay, here are Dr. Ziad, when you talk about UK alarm is as a measure or as a reference for risk. The French also, they have something globalement aussi ou aussi au moins équivalent and to some figure. And the German, they have something they call minimum indigenous mortality number. Okay, you have here also some figures. Maybe Dr. Salma would share it with me, but they can estimate the value of the severity when it touches human being. I mean, a fatality, it could be 1.5 million. But this is the tip of the iceberg, as Dr. Hanan told. What's the compensation for orphanage, for instance, is not considered in these figures. Incapacitative injury that would not allow the person to work a certain period of time, a serious, slight, minor, first aid, and so on. These are figures or tables, but these are relative and they vary from one country to another. Risk here bears, I mean, Dr. Ziad talked about societal or individual risk. We consider different values and different criteria. Always the workers, they accept higher risk than the public, because the public is not supposed to receive certain hazards found in the workplace and so on. There are always one order of magnitude less for the risk on public than for the worker. So the risk considered to, and the worker, because he's exposed to more risk, he is also protected by a lot of the protection hierarchy, elimination, engineering, PPE at the end also. Okay, I'm moving to analogy. We talked about analogy almost 3 times today, between decision making and risk management, as engineering said. I found a very close analogy between waste and risk. I consider personally whatever loss or damage for a given resource is a type of waste. It is not waste related to environment. It's a general view for the word waste. Waste has a cost in money, or has a cost in life, as maybe long time or short time, or it may influence the environment, the atmosphere. So actually, total quality is a process that targets minimizing risk and waste. Waste is always taking part of the resources in order to produce something good for the humanity. That's why 100% efficiency is impossible. The equivalent to this Zero risk is a fallacy. Zero hazard doesn't exist. Perfectness is a quality of God. So actually, the total quality, the risk management, the environment will all talk about something negative subtracted from the resources used by humans. And this is why we will end this presentation by calling for a general science that groups all kinds of waste. The same terms we use for the risk: unacceptable, tolerable, acceptable, negligible. We put values. It's almost the same. We can exchange it. We can use four colors for the waste to rate these levels, like the same as we do for risk. Now, to terminate this part of tools, we talked about a lot of tools and models. That Asperg model, the risk management and model, and the decision-making model, the analogy, the divisions of risk management. When we want to evaluate risk and control it, we should pass by the 5 steps. This is a model for thinking and model for perfectness also. The model of that any event or any object or any accident, it has something, a birth, operation, maintenance, some form. We use analogy here to discover it. If we don't know, we'll go outside and check what happens elsewhere, and we make analogy of it. We had signs. Signs why? Because we cannot write phrases and sentences on the road for someone to read it while he's driving at 100 kilometers per hour. So science is very effective way to communicate a message. Dr. Fatma talked about barriers and cheeses and things. Here is an analogy between what we eat and what we face. The holes in the Gruyere, these are defects, undesired events, accident, incident that allows the danger or the undesired event to continue its path until it causes an accident and risk. Okay, the application we will handle will cover something practical. Maybe I'll start with an application in a drilling. Why drilling? Because I noticed that most of our audience in a list sent to me by Dr. Ahmed Garhi are petroleum engineering students working there. But our application, they don't cover petroleum engineering only, they cover a lot of things. I'm going to go through the first model. Dr. Hanan is going to talk to us.
Okay. Okay.
Go ahead.
Okay. These are the first application. It is about the culture application, about the culture of risk. You should, when you go to enter in any new place, you should take an issue in the plan. As we mentioned yesterday, when we saw the kids, we say that you should take safety not in the yourself only, but I should think about myself and others. For that, you should at first, when you enter any place, you look to the plan of the place and begin to remarks. Where is the exit doors? Where is the exit arrows? Where is the exit lamps? Because when the fire will happen, the lamps, the light will off and the lamps begin to light. For that, you should take anything, look to everything you can see and put in your mind. And as Eisenberg said, some things are known and very clear and some unknown. For that, if you don't know anything, you should ask about the emergency plan. You should ask about evacuation plan. You should ask about the assembly points if you're not seeing. You should know everything you maybe needs. When I enter any place, I should search about the nearest exit door, because if anything will happen, I can escape for that. 4, you should remark everything, and then if you don't remark, you ask safety coordinator about this thing. Here about this picture, like another picture Dr. Fouad speak yesterday about it. When I saw this picture, the first thing, because I try to raise level of awareness, the first step, if this happened in my house, I will stop him from the maintenance or from the work, because he's not aware about the he don't know about the safety issue. And also the company or the which are responsible about this will not allow for that and not trust about their application or their job. For that, he break the rules. First thing you should, if you are in this case, you should stop him from make any maintenance or any service, because he break all of the rules, and take in your consideration that it is maybe the probability will increase when we know from which level he are, and the severity also will increase. It is unsafe situation. For that, stop this thing from complete. Okay.
And here, the first thing to blame is to blame the system in which this happened. Don't start by blaming the person and not changing the system. The real issue, the real solution is to change the system to prevent the recurrence of such situation. And this is Dr. Ziad can expand on it. Go ahead, Dr. Ziad.
Yes, Dr. Fouad. Here we face two problems. Number one, behavior. The kids stand on electrical panel. Number two is electrical hazard. The first rule is that inappropriate behavior is usually a result, not a cause. How we can improve the behavior-based safety in the society and in the work. Number one, we must eliminate the causes. The causes may be lack of accountability, no supervisor, lack of training, lack of communications. This really the safety behavior-based safety is a problem in the society and work that must be take rules to change it. Number two is electrical hazard. Electrical hazard, these children may take electrical shock. Electric shock means contacts with live parts. That means current flow through their bodies. The electrical hazard may include also arcing. Arcing, that means electricity can jump an air gap, causing shock effects to persons not in contact with conductor. Maybe fires. Fire follows the electricity, generates heat. If large flow passes through unsuitable conductors, heat can lead to fire. Number four, burns. Heat of arcing or excessive flow through body causes tissue damage. This is my remark for this picture. Yes.
Okay, here again we blame the system. Even the passers-by, the people passing through the street, they never intervened here or told them a word. Go continue, Dr. Ziad. You prepared some other slides.
We can introduce here a hierarchy of control on our house. hierarchy of control as we talk, elimination, substitution, engineering control, administrative, and BBE. Elimination, warehouse hazard. At first glance, it is easy to assume that this top level of control is not visible in our house environment. Our house requires people to operate the equipment and move materials in the name of logistic, but an automated storage or automated storage systems that in the picture, in the left of the pictures, deliver an environment free of people and powered industrial vehicles. Since automated storage systems is fully guarded and automated, the likelihood of exposure to energy, failing pallets or loads, and forklift collision is zero during operation. Number two, substitution. Substitution of one risk element with lower risk. One example, it's easy to replace is substitution a personal clothing uniform with high visibility uniform. A pedestrian crosswalk that had been made due to the road traffic can be substituted like for like with a crystal clear project image. Engineering control, anti-collision technology is available on most forklift platform, offering both radio frequency and ultra-wide band mechanism for identifying pedestrians or other forklift traffic. Antenna are installed on forklift and tags are worn by pedestrians such that an inner and outer band are designed as bubble. Administrative control using the policies, procedures, and rules as administrative controls. BBE, personal protective equipment, is a use of both steel shoes and high visibility. We can use engineering control and administrative controls and BBE all of together to control the hazard at the time.
Okay. Thank you very much, Dr. Ziad. Now I'm going to talk about driving. It's unenjoyable sometimes. It's a way to gain to work. It's a tool for work. So driving, I didn't put here the risk matrix, but all the elements of the risk matrix, the creature, you can find it in here. The human being. And also this list, it may not have animals in it. I mean, donkeys, camels, and so on, and talk about creature. If I talk about infrastructure, the road itself, that state of the road, okay? If I might talk about human being behavior, you will find it, the speed, the use of drugs, being reckless. If I'm talking about environment, yes, weather, fog, dust, storms, the way you use the mobile, this belongs to the human being, okay? And there is a model of thinking before and during and after. So before driving, what we should do, check the tires, the water, the oil, the load we have, check the gasoline, and so on. Something belongs to the human being, also distraction, use of drug, being alert, slept very well the day before. Ethics, we find it in number 2, travel restriction and respecting the red light and so on. Those who are driving, their age, their gender, the lifestyle, how recent is he start, did he start or she start driving, recent or not, is he aware of, is he a foreigner coming to drive in a country, he doesn't know about the behavior of it. he will be vulnerable to more risk than even the citizen of the same country. Okay, so this general model is extracted from the system model having 8 elements, and we talked about 8 times 7 makes 56 reactions. But if I'm going to talk, has accident happened and I'm going to talk after, is it detected early, the accident? The ambulance came at a certain, quickly. Do we transfer the injured person to the hospital immediately? Should we follow also the cause of accident with the injured people right after it? Not necessarily the same day to build our statistics. In Europe, they relate the sources of the accident to the fatality 1 month after. If the fatality happens or the death happens 1 month after and is related to the source of accident or the reason why it has happened, it is charged to this in the database. It is not in the same day. Some countries sometimes even use a longer time. This is an example of when we study something and we go and bring the models and the matrices we're talking about. This way we can cover the topic in almost perfect. Perfect doesn't exist because there are certain things. Also, the kids driving and putting the kid on his lap. This is very common here, and it is prevented in certain other countries. By having a motorcycle and not having a helmet, this is how do you call it? This is a near miss. We call it in risk. This is something undesirable intervention in say in other cultures. Okay, now risk management in medical. The 6 coming slides, I would like to shorten it because we have now somewhere around 15 to maybe maximum 20 minutes.
Okay.
Salma, go ahead.
Okay, Dr. Fouad, happy to be with you. Let me, in short, tell you that medicine deals with uncertainty. We are dealing from the history of patient. We don't know what is the diagnosis, what the investigation results, what is the management plan. So we are dealing with uncertainty from the beginning, and risk is considered in the diagnosing of disease, in its causes, and in the management, whether medical or surgical management. Health compensation that should be in balance, physical, mental, social, environment, and spiritual. This is my comment for the question of yesterday about compensation. Because health has 5 pillars. Patient safety is best example for applying risk management, use the terms, and reflects it. In patient safety, the goals are mainly to identify the patient correctly, improve effective communication, improve safety of high alert medication, ensure correct site, correct procedure, and correct patient surgery, reduce the risk of healthcare associated infections, and also reduce the risk of patient harm resulting from falls. Many, when we make documents, okay, types of and examples of error, they are not different from that we have discussed before. Adverse healthcare event, omission or arising during the clinical care, causing physical or psychological injury to a patient. Error is the failure to complete planned action as intended, or the use of an incorrect plan of action to achieve a given plan. Healthcare near miss, it is the same as we have said before. Adverse drug reaction, a response of a drug which is noxious, unintended, that occur at doses used for prophylaxis, diagnosis, or therapy. Medical errors, preventable event, inappropriate medication use and causes patient harm. Sentinel error or surgery on wrong body part or the wrong patient receiving the wrong medication. We should discriminate between errors or mistakes and the complications of therapy. This is for doctors, not for you. When we come to types of safety, they are the same: environmental, medical safety, surgical safety, electrical, laboratory safety. Very important, because we have a checklist for safety in labs, as Dr. Hanan told us. Sanitation, infection control, and blood safety. This is a big category. Equipment installation safety. We follow, next slide please, Dr. Fouad.
Yes.
Yes, to minimize these errors, in the beginning, we should tell, as you teach us, what is the terminology we agree upon, because sometimes we use errors, sometimes we use mishaps, sometimes you say mistakes. So this is for discussion. We use the checklists that of WHO, and this is the best example in surgery, pre, during, and post. Proper techniques, and this needs the training, of course. Full documentation, very important documentation, because we return to them and we fetch and make many researches for this. Incident reports, there is a process of incident report, and we should make environment and culture of no blame, no punishment, to learn from errors. So we make meetings for mortality and morbidity, and to allow people to tell the truth and to discuss the mistakes and try to overcome them. And when we discover defect, we make training, we make awareness orientation. This is very important. Next slide, please. These are the list of WHO for the sign in, sign out, and time out and sign out. This pre, during, and after closure of the wound. This is the shortest presentation I have made. This is a special reduction for you. Thank you.
Okay, now an application on drilling profession about selection of casing tender. Okay, we do have in the Gulf of Suez certain formation active salt that can push on the casing and causes collapse of it. The problem was that in the past we were running a lower grade 9 and 5/8 inch casing, and the plan was, say, I'm imagining a situation, a drilling plan for 40 development wells. The source of undesired event is an active salt bed between 10,000 to 10,500 TVD. I'm using terminology for drillers, but it is following the same principle of risk we are talking about. The undesired or feared event in this case, we run pipe, we cemented it, and then later on we discover it collapsed, it's been damaged. Why? Because the salt moves with time and closes on the pipe, and the pipe is not designed for this. So what is the best way is to select a pipe that can resist this for a certain period of time, which is the life of the well. In this case, the event we are going to talk about is we want to issue a tender for 40 development wells for 500 feet per well, majorated by 10% more, and we will introduce risk management in the evaluation of this tender. The objective is to show how risk influences the decision making. The apparent decision goes to the left. With risk, it is the right decision later on. The quantity we have to purchase is a quantity for 30 well, sorry, I changed the figure, 30 well, 500 feet per well. This means we have to order 420 joints of casing of special high collapse resistant casing. Bidders supply in their technical envelope some test data run by the mill while manufacturing the casing, and will be used later on to define a probability of failure or probability of satisfying requirements to prevent casing collapse. Okay, what we do, the parameters we have data on the collapse resistance of the casing from two companies, Company A and Company B. They gave us, say, 50 data. What's the average of the collapse resistance in pound per square inch? It is 10,850 for one, and B is higher. Higher is better, but we will see later on, maybe higher is not better. Standard deviation, here standard deviation plays an important role. Dispersion, synergy between the test is high for A than for B. The Z factor, which is determined and defined here, the Z factor is 3 times the standard deviation, standard deviation for A, and only 2 times for B, and this is very important for the decision later on. What's the probability of having a pipe less than the desired value of 10,500? Because if it has something less than 10,500 psi, it's going to collapse sooner or later, and we lose a whole well. A well may cost between 5 million to 12 million and even more if it is offshore. So the probability for A is 10 to 9 to the 10 to the power 10 minus 4, 0.09%, and for B is 0.006%. Now the number of joints, if we apply this probability on the number of joints, which are a number of 420, A in the lot of 420 joints, there is a fraction of a joint. Then I would say there is no joint below recommendation or below desired value. Whereas for B, we have 2 or 3. Okay, we don't know them. They are stored in one place. Sometimes when we pick casing by hazard like this, because all of them of the same grade, maybe the 3, we will run them in one well, or maybe in 3 wells will be even this catastrophic. Okay, bidder A supplies satisfying requirement. Why? There is no one defective joint in it. Bidder B gives us 2 to 3. The 3 joints may be used in 1 or 3. Okay, what if one well is damaged? The cost will be of the order 5 to 7. If the 3 are, then the cost can go to 21 million. Okay, what's the difference in cost? This is 700,000, 6,700 is the difference in cost between A and B. B is cheaper, $30,000. If you go with the administrator and the people and select the cheaper, you may run the risk of damaging up to 3 wells, costing you 12 million or even 21 million dollars. So actually the decision is to select company A. Conclusion, company B provides the lowest offer, but company B casing may entail the risk of losing 1 to 3 wells. This may cost the company between 5 million. So on recommendation, accept the higher bid against maybe the common law we have, but there are technical justification for this. Why? To avoid potential loss of 5 to 15 million dollars. The comment: potential saving five for this decision, potential saving from 5 to 15, cost of awarding the tender company cost us a sure loss of 33,000, but the cost benefit ratio is in our favor, is just only 0.2% to 0.7%, and this is negligible and acceptable, and it's even less than the insurance we have it for 1 well. So this is an example of how if you introduce the risk to the tender, and this is a short example for drilling, you can invert the decision. Okay. Now to approach the conclusion, I think running a bit late, 5 minutes. Risk management perceived this way is a continuous improvement process to control undesirable situation, to bring it to the better. Improvement it addresses all resources. Risk management targets all sorts of waste. Now we talk about waste. Now we talk about risk management. We talk about evaluation of tender, especially those hindering safety or objective of business. Effective risk management improves efficiency of the whole system. Why? Because it targets synergy, achieving total quality. This is very important. Efficient risk management managers are leaders, by the way, because they are very close to human beings. Risk management is an efficient way to manage business. Improvement of a system efficiency is a measure for the success of risk management. As a result of running risk management, you will get a system efficiency, and this is the objective of conventional management. So we can achieve the same objective through risk management. The sub-product of risk management is better management of management resources, less pollution, achieving or having clear environment. Why? Because we don't waste, we don't pollute. Better social rapport, which is the distinction between risk management maybe and other forms of management. Better quality of life, sustainable development, because we maximize use of resources, and if we maximize it, we don't waste, we leave something for the next generation, so we will be praised by our kids. Many other corollaries will exist, and you will find later on that the progress, the economy, the state of life, and all of this of the country who observe risk management is a place where people like to live in. Risk performance permeates through the whole system. It's a general conclusion. We would like now to propose what we designed for this presentation. We would like to have a general science of waste, say, of danger, of something that hurts resources. And this will represent the trunk of a tree. Is going to feed back into all sources that targets human safety, say risk, crisis management, environment, resilience, something cherished by Dr. Fatma. You want to say something about resilience, Dr. Fatma? Or
Yes,
leave it for the
yes.
next slide. So, the signs
as
of
you wish,
danger.
doctor.
Then the next one, you have resilience.
Okay.
So actually,
yes,
this what we propose, it's an umbrella. Risk management here, or the science of danger, it is an umbrella or a tree that sheds shade to all other sciences. Now, systemic risk management is a transdisciplinary science. We saw it in timber, we saw it in medicine, we see it in chemical, we see it in radioactivity, others. The synergized knowledge of the whole will have myriad of, I forgot have here, will have myriad of advantages. Okay, what signs of danger we are talking about? Risk management, crisis management, health and safety, industrial hygiene, ergonomics, reliability, ecology, epidemiology, emergencies, disaster, and Dr. Fatma will say few words on resilience.
Yeah. So resilience is the ability to return, to absorb the perturbating anything that happens. Okay, so resilience is defined as the ability to return to the status quo. Risk management focuses on planning and reducing vulnerabilities, but resilience management puts additional speed in recovery and facilitating adaptation. So this is the future. This is risk plus resilience.
And yes, there is an analogy between risk management, the way we talked about, and resilience. Resilience is steadfast, face a problem, absorb it, recover, and then get back to. This is include optimizing resources, being what? Prepared psychologically, prepared psychologically to problem. And resilience now is gaining ground in the world after the coronavirus. Everyone in the world suffered from. So we would like to stay steadfast in front of this problem. We lost a lot of things. We should not be desperate, because if we are not desperate and armed with psychological tools, we can recover and go back and even exceed the previous situation. Thank you very much. So I finish this with a call. Now, signs of danger. I hope that we spread the word. There are some in the world that can join us, researchers. I know in France, they like this, and they can, this is going to create a lot of research for the academician. This is going to spread the word so that we can use our resources in a better way. This is calls for cooperation. For any one of us hearing us, please respond to the call. Let us continue this contact, make a forum at least, because there are people very well advanced in this somewhere and would like to benefit from them, because this is going to shorten for us the way to achieve continuous improvement, to achieve system thinking, to achieve synergy, risk management, resilience, and also protection of the environment, and finally, for the benefit and the welfare of human beings. Thank you very much. Okay, to Jumana or to Dr.
Thank
Ahmed.
you, Dr. Fouad. Thank you, all
and
the team. Thank you, Cairo University. Thank you, Marita.
Thank you all. Thank you so much. It was enjoyable.
Thank you. Thank you all.
Thank you. I'm really proud being part of this team.
Thank you very much,
Okay.
everyone, for this extremely insightful and informative session.
Maybe Dr. Ahmed, since you are the initiator, you can make a call or a corner or your things about who is willing to cooperate, at least share with ideas anyhow, or contributions, contribution with scientific publication.
Dr. Fouad, I saw one question about petroleum in
Yeah.
the petroleum engineering field. If you can please answer to finish all the
So
questions from.
I believe we have like three questions, and Rahima will ask Dr. Fouad one by one. So
Good.
Rahima, you can go ahead
No,
and
yeah,
ask the
you,
questions you received.
you help me sometimes I miss certain words. I don't want to miss something because this is a waste. Go ahead.
Thank you very much for this extremely informative session. I really appreciate it, and I'd like to ask the question of our audience. So the first question is: in the petroleum engineering field, which stream is totally dependent on numericals, problem like production, drilling, and reservoir?
Okay, as I understood, I repeat the question. Petroleum engineering has three legs. I don't see an animal with three legs. It must have more than this. It's drilling, exploration, drilling, the production, reservoir, and then I think the cousins and the sister of petroleum is also what we do with this with product. Maybe the one who asked it, what after petroleum? Is it going to finish or and so on? I would say, with what we concluded, if we save the resources, we will extend the life of the oil. And our profession as a petroleum engineer will stay longer. We should not waste petroleum engineering on something trivial. We should really want to use it in something that adds value and maximizes the use of it for the next generation. Did I understand the question? And if not, repeat it again, or maybe there's something missing from it.
The question was, in the petroleum engineering field, which stream is totally dependent on numericals? Problems like production, drilling, reservoir.
Totally dependent on what?
Numericals.
Dr. Fouad, I sent the question in our group.
Go ahead.
You can read it. You can read it.
No, I don't have access to it. You tell me what's the word. I mean, it's related to. I didn't catch
numericals.
Numerical.
Yes.
Numerical means mathematics and things like this. It
yes.
is required. It is a piece of knowledge very important. When I talked about casing and tender and evaluation, statistics is a science of life. I don't think a petroleum engineer without statistics, he will be a successful petroleum engineer. As a petroleum engineer without risk, he will not be a successful petroleum engineer. Economics and statistics and computer knowledge, these are basic skills. Basic skills not only limited to petroleum engineering, it's required by a lot of discipline. And these are multidisciplinary skills. I mean, numerical, Dr. Selma can talk to you about statistics and how we use. I personally would like to have in our department a statistician, someone involved in statistics and has a PhD. And two things we are missing: statistics and economy. Statistics and economy. Life without economy, petroleum without economy, without statistics, it's not. I mean, and I love statistics. I like it. Why? Because I felt we used it in GAPCO to limit lost hole, to deal with data. We have tons and tons of data. We throw it in the garbage and we don't use it. And this is an asset, very valuable asset wasted. This is my understanding for the question. Don't be ashamed of being a statistician. A statistician can solve a lot of problems in petroleum, outside of petroleum, and things. This is my opinion.
Yes, this is very scientific answer. Very scientific answer. Statistics are prerequisite for the university before any research and before studying any postgraduate. Very important. Thank you, sir.
This is not only for scientific. Go in literature, go in psychology, in sociology. I mean, all around us, we are immersed with valuable data, but it's a near miss. It's an opportunity in front of us, and we don't use it. And missing opportunities, it's not good for someone, for a country, for a group, for a team. And one of the opportunities you miss if you don't know numericals, like you said.
Thank you very much, Dr. Fouad. And another question is, why there is a room for risk in petroleum system? Why we cannot cure it from its root?
Why? Repeat it, or someone repeat it to me. Why
there is a room for risk in petroleum system? Why we cannot cure it from its root?
No, there's risk always everywhere. You cannot risk.
Let me please. We always say we don't have zero risk system. Yes. We may have zero accidents, but risk is existing all the time.
Okay, but accident is a higher form of risk. But sometimes I'm drinking water. Now, I drink too much or too little. I mean, life without undesired event, we are not created. We are not created this way. No one is going to stay forever on earth. And why? Because we are created this way. I mean, because of zero risk is a fallacy. Because perfectness is only for God. And something is not perfect is going to die. This is going to die. I don't have the time, but I can prove to you on Excel that a system wasting 1 to the power 1 multiplied by 10 to the power minus 6 of its resources is going to die maybe in 50 years, 100 years, 200 years. I mean, but what I would like to know, we are late in petroleum. Late about what? The question, late about what? The one who asked the question, they said, we are late. Late about what?
Actually, there was not late word. It was like they asked why there is a room for risk in petroleum system, why we cannot cure it from its root, not late. Root.
No, there is can I make a comment? There is a room, or go ahead. Someone,
yes.
Tell me the question. I can. There are missing.
Dr. Fouad. Dr. Fouad,
Dr. Fouad, he asking why it is not corrected at the root. As we know the risk, why we don't correct it from the root? If I can answer, you correct
one thing. We are human beings.
Yes.
We are not synergized. All of us, they don't think the same way. Now, if synergy in a certain group, if synergy in a certain group is very well developed, they always attack the root cause and make root cause analysis. But we are human beings. We have conflict of interest. We are selfish. Selfishness of countries, selfishness of societies delays sometimes certain things. Go to the curve of ethics. And people, I mean, the countries with a very high ethics, they have a very high synergy. And maybe the chance of correcting things by starting correcting the root cause, there it is existing, has a chance to be adopted at any. So Dr. Fatma, maybe you would like, or Dr.
Yeah. I say something. Maybe they are applying certain technology and the technicians are not well trained. So there will be room for an error. There will be risk, I think.
Yeah, there's also, we don't like change. We are an established situation. We are comfortable where we are. We don't like the change. But the risk is a continuous change towards an improvement. Change every day. And this is a character. This is a, how do you call it? We resist change. The human being like comfort, but he
Please, Dr.
doesn't
Fouad,
like
if
developing
they,
effort.
can I
Okay.
say something? If they
Yes, go
choose
ahead.
to be in their comfortable zone, so they are in risk situation. Do you agree?
I agree. Why? Because the
Yes.
comfort. We
Yes.
talked
If they
yesterday.
stay in their comfortable zone, they are
We
in
we
risk.
yesterday we go the second law. I mean, the second law of system thinking. Every problem has several solutions. One of them is optimum. Seize the opportunity and change immediately. We are not always all accept this, because a change for someone is going to hurt the comfortable situation of another. And this optimum solution is only valid for the space, the location, and for a certain time. It will never stay forever. This is the way. Why? Because time is driving us. No one is eternal. No one is going to defy time. And time is changing us. If we would like to be comfortable with time, we have to change with it. And this change is addressing the root causes of our problem. If we address the root causes of our problem, we'll end our life in a good comfort, I mean good life without problem. But the end is inevitable.
Yeah.
Okay, other questions to our colleagues at least?
Yeah.
Okay, if we have with Dr. If any other questions, you can address it to Dr. Ahmed or Rahima, and you have our emails, and then we are really willing to, because what we talked about in the 2 days, these are references for me for answer. And answer is in the system thinking. If you address a question to me, I put it in a system. I apply n times n minus 1. I can find n multiple answers. And I can forget a lot of them. But at least I don't have one answer. I can, you see? And this is the way to agree on team and to have a good social rapport. Don't monopolize your idea. Meet halfway. But the only thing, don't trade your ethics. Don't exchange your ethics. The ethics are permanent. Say truth, saying the truth, it is a good thing in any part of the world. Justice is a good thing in any part of the world. It's okay, fine.
Thank you very much, Dr. Fouad, and our instructors. And my last question is there any limitation on international level to make symbols of risk in industry, or anyone can make any type of symbols to show the risk?
Excuse me, because I've seen this question, but there are international, if I might answer, there are international.
They are international.
Everybody. So this is a language. So everybody should know that these signs represent this type of risk. So everybody will know about it everywhere. So I think that if you invent something, a new one, you have to go to the international organization or something for them to adopt this sign and to be spread everywhere. I think this is the answer.
Yes, they are franchise and internationally known and used all over the world. Danger is danger everywhere. Fire mark is fire mark everywhere. As the traffic signs, they are international.
Yeah.
Yes.
Thank you very much, Dr. Fatma and Dr. Salma.
You're welcome.
Okay, I saw the questions here written. Okay. Can you address this question to us so that can answer Salman Khan about Sanhaji, Asamu, Badi? Salman Khan also answered asked two questions. Maybe Abdel Alim Mahsar, also Salman Khan. And the petroleum.
Dr. Fouad, I have already mentioned those questions to you.
Oh, okay.
Some of our questions already have been answered by our instructors, Dr. Fatma and Engineer Reem. So thanks to them. So we don't have any more questions now.
Fine, thank you.
Thank you very much for answering our questions with special attention. Also, everyone, please do not forget to finish and submit the quiz before deadline. Moreover, you can rewatch this lecture again from Petra's YouTube channel. Stay safe, everyone. Thank you.
Thank you. Thank you.
Thank you very much.